Hello everyone. In this session we'll be discussing about the next category of load store instructions, which include the swap instructions. Okay, so first let's see what exactly do you mean by swap instruction. So this particular instruction is used to swap a register value with a memory location, and this happens atomically. So what do you mean by atomically? That means when any read or write operation happens on a particular memory location, due to this particular instruction, that particular memory location gets locked. This particular memory location cannot be accessed until the concerned swap instruction doesn't get over. Okay, so once this particular operation is complete, any other instruction can access that specific memory location. We see two different instructions here. This is if you want to swap 32-bit data, and this is if you want to swap 8 bits of data. Okay, so let's discuss each of these instructions in detail. So let us consider the very first instruction. So what happens here is we have three registers RD, RM and RN. Okay, RN is not holding the value, it holds an address which points at some particular memory location, and this particular location will have some data. Let's assume some data Y. Okay, and let's assume RM contains some data X. What happens after this swap instruction is that this content gets shifted here and this value gets shifted here. What it means? RD will get the value whichever is stored in the memory location pointed by register RN, that is RD will be Y, and RN content will be X. Let it be SWP, that is swap R1, R2, content of R3. Let's assume R3 holds some address 800 which points at this particular memory location. Okay, let this be 801, 802, 803. So let it be something like 1, 2, 3, 4, 5, 6, 7, 8. This is what is stored in the memory. Okay, then what we have is nothing but, let's assume our register R2 holds a data 0x8, 1, 2, 3, 1, 2, 3, 4. Okay, so these are the two values already stored. R1 can have any random value, we don't have to think about it. Okay, now once this instruction is executed, what will happen is R1 will get the value which was stored in the memory location pointed by R3. So what is that value? This value. So it means new R1 will be nothing but 0x1, 2, 3, 4, 5, 6, 7, 8. How did I get this particular value? Because highest memory location content should be placed as most significant byte and lowest memory location content should be placed as least significant byte, because we follow Little Indian system. Next what we have is what happens to the content of this particular location. This remains same, R3 pointing at 800, 801, 802 and 803. So what happens here is new values are updated, that is you will get 8, 0, 0, 0, 0, 0 and 0, 4. Okay, so that's what happens here. So now if we change this particular instruction, let us consider the next instruction, that is nothing but swap a byte of data and let all the other things remain same. Then what should happen? In this particular case, if we consider this instruction, this works in the same way. That is register RM, whatever content is there, it gets stored in the memory location pointed by RN. Whatever address is pointed by the register RN, that memory content is now loaded to register RD. If I perform swap B, okay, that is swapping a byte, and for the same registers, what exactly should happen? The concept here is only a byte of data is transferred. So what does that mean? Now from R3, instead of loading entire data into R1, only a byte, that is 78 is loaded. All this remaining bits are filled with 0. Okay, it's unsigned data transfer. Okay, and what happens to this content? What happens to memory location? Only the lowest memory location gets modified, that is this remains same, and 78 gets replaced with 04. Okay.